Hi guys, we're currently 13 and 17 now, right? Right now, we NFL Week 7 predictions, Niners 1.5. This is against, I believe, Atlanta. Atlanta consecutive upsets is a very unlikely, especially in prime time. They upset Sunday night and they also upset Monday night. So very consecutive upsets are very unlikely, especially in prime time. So that's why Niners -1.5, Steelers -5.5 consecutive. Two times now, actually, 2 weeks in a row we had consecutive TNF upsets 3 weeks in a row. Very unlikely. Commanders -1.5. This is with the Cowboys are underdogs, and Cowboys almost covered. They did cover, but they almost pulled off the upset in primetime SNF. So unlikely they do it here. Broncos -7. This is, I believe, another trend where it's like, uh, oh, I think this is with Broncos. This is with a team that was supposed already did a primetime upset, and we're saying that they're not going to do it this week. And then Rams -3. This is against the Jags. Jags have also have done 305 upset against the Niners, so unlikely that they will do it again. So that's our entire system of predicting these upsets. Is we're trying to or predicting these games is we're trying to pick the upset to not win in prime time again, right? Or to upset in a primetime game again. Right? So that's the logic there. We're 13 and 17 right now, and we'll continue to stick with the system. We'll see where it gets us. So again, Niners -1.5, Steelers 5.5, Commanders 1.5, Broncos 7, Rams -3. Now let's move on to some additional ASTAM notes. So here, always know that when you're doing the PGF and you're trying to calculate the probability x equals n, the zero is always with like the larger expression between do I evaluate it at zero or do I evaluate it at one? You evaluate it at zero when it's the larger expression. Probability of x equals n is PGF, the derivative of PG, and the derivative of PGF evaluated at zero over n factorial. Now, if you want to evaluate the first, right, then you take the nth derivative, evaluate at one, and that is e times x, and so on, right? But one thing to know, one easy way to remember is you evaluate it at zero if it's the larger expression. And then MGF is always zero. Larger is zero for PGF, but MGF is always you evaluate at zero. That's a way to remember it. And the compound is something you need to make automatic in your mind to remember. We know that if S is compound, frequency severity, then it's PGF, and then the MGF of MGF of the compound is the PN MXZ, and then PGF of the compound is the probability, the PGF of the frequency evaluated at the PGF of the severity of Z of X at Z, and then GPD. The idea is pretty simple with GPD. If X follows GPD, we know that the mean excess or the X minus D given X is greater than D also follows GPD with those parameters. And then you want to retain the general X when you're calculating variance or Fisher information. And when you're calculating Fisher information, you only need to take the natural log of X. You don't need to take the natural log of the entire summation of X and do the entire likelihood. You can just do of f of X and then multiply by n to get the Fisher information that which you invert to get the asymptotic variance. KS test only for continuous fit and individual. Estimating parameters when you do estimate parameters, you decrease the KS test stat or critical value slash test stat. LRT H1 is always the more complex model, not H0. H1 is always the more complex model, and the LRT test stat can never be negative. So H1, right, the likelihood at theta 1 will always be greater than the likelihood at theta 0, right? Because if you have more parameters, you will always have a greater max log likelihood. Normal, log normal, normal, t-var are important to memorize. How you can memorize it? Well, t-var of x, you know mu is the mean, and you're going to add the standard deviation times the PDF of ZP over 1 minus P. Right? So you can think of it as PDF, right? PDF of ZP, right, over 1 minus P, right? And so that's that. And then premium collected equals the written, which is that's what is assumed, and the unearned equals what is written, so aka what is collected minus the earned plus what was unearned from the previous year. Zero truncated geometric. If it gives you the mean of a zero truncated geometric or zero truncated any distribution, the mean is always after the zero truncation. When you do, and then another thing to know is Excel distribution calcs. A lot of times the parameters are slightly off than what you would typically expect. For example, expon.dist, it's 1 over lambda, so you want to make sure you provide the 1 over, you're not just providing the theta. And then some of these balancing back is always dividing by the off balance factor, not multiplying by it. And then some of these other ones. So if x follows log normal, natural log of x follows normal, x follows normal, e to the x follows log normal. And then Borg BF method, there's multiple different ways of doing this, right? We know the first way of just getting the ultimate loss reserve is doing mu I, weighting that. And so it's the weighted average between mu I and then the chain ladder. We give what weight do we give the chain ladder? We give the weight of 1 over we give the weight of beta, right? Beta j, which is the estimated proportion of ultimate claims weight, and then 1 minus beta j to mu I. That's the estimated ultimate claim amount. We have two different quantities. We want to weight them, and then that's the final amount. BF reserve equals CF reserve, WI plus 1 minus WI EL reserve, right? Where the WI is 1 over FI CL. So the reserve is also the weighted average of between the CL reserve and the EL reserve. CL gets 1 over FI. Right? Which is, 1 over FI cumulative. Yeah. And then BF ultimate estimate is also another way of writing it is mu I times 1 minus 1 over FI. It's another way of estimating it. And I think that covers it. Oh, smooth empirical quantile is also something you should know. So you have XB, where B is referring to the B smallest value in that sample. B is the floor of alpha n plus 1. C is alpha n plus 1 minus B. And then take the weighted average of those of the first B and then the B plus 1 smallest. Expo theta is gamma alpha 1, Weibo tau 1 theta, geo beta negative binom r equal 1 beta. And so those are some just sticks. Log likelihood always increases as more parameters are added. So those are some tips for ASTAM.